Hi everybody, this is Steve, and this is a short video about Synapse Server. So, what is Synapse? At its heart, Synapse is a fast, easy way to create a REST API. Synapse allows for subject matter experts with some technical skill, full developers, or operations professionals to participate. Synapse is built to be a strong enabler of DevOps. Synapse is very flexible in its construction. It executes either scripts or compiled code. Scripts can be written in any OS-supported scripting language, and code can be written in any .NET language. The execution engine in Synapse supports a state machine-based workflow processor. The workflows in Synapse are referred to as plans. You can compose scripts and code in small reusable chunks, use them in the plans, and then expose those plans as REST API endpoints. Synapse comes with a default URL implementation, but it's easy to create a custom new URL scheme suitable to your specific requirements. In addition, you can author custom modules that extend the base capability of Synapse itself. Like all products, Synapse includes a rich security subsystem, and it provides multiple modes for authentication, authorization, and low-level plan RBAC. By default, the security subsystem supports Active Directory as a provider and itself as a provider, but it can easily be extended for other providers. It's possible also to disable security altogether, which may be useful if you're running Synapse as a subcomponent of another application. At runtime, Synapse leverages a distributed execution pattern, and it can be run on one server or many servers, however you need to go, running in any direction. This is especially useful, for instance, if you're trying to bridge an on-prem environment and cloud or multiple cloud environments. You can start execution in one data center and finish execution in another. Lastly, Synapse is an open source application and free for use. All the code is hosted on GitHub, and we welcome contributors to report bugs or a code fix or even create a new feature. Okay, so a little bit about the architecture. Synapse is made up of a controller and a node. The controller hosts the API itself and accesses plans from the data access layer, and the controller also enforces security. So a user makes a call to the controller. A plan is fetched from the data access layer and forwarded to a node. The node is what is the worker unit in Synapse. It runs the plans, has all the technical capability housed at it. So the node can run agentless and access remote resources like databases, servers, or other kinds of application endpoints. Or and you can install a node perhaps on a server and run it as an agent-based type of setup. So if you need to access resources locally on a box, you need local access to them, and then you can install Synapse node as an agent, or you could just run it and access assets remotely, in which case it's running agentless. So like all of Synapse, it's very flexible on how you configure and run this. Agents can be daisy-chained for multiple kinds of execution patterns. This is the basic paradigm that we use to support multi-cloud / on-prem style execution. The controller can be located in one place, and the nodes can be located all over the place. And node daisy chaining makes it possible to move the workload as you go along. All right, a little bit about the workflow in Synapse, referred to as plans. So plans are written in YAML, which is just a data serialization format. And it's similar to JSON, but with carriage returns and spaces as formats. So it's human readable, easy to look at this. You can generate the plans from code. You could write XSLT to take files and generate these kinds of plans, or the plans can actually rewrite themselves. It's possible to include core components of Synapse that will extend the plans at runtime as it goes, which is useful in truly dynamic requirements where perhaps your data is determining what the next steps are if you don't necessarily know what all steps might need to be included. Lastly, the plans can be stored as a function of the data access layer in the Synapse database at the data access layer itself or at any URI. So you could store the plans, say, in source control or on an Amazon S3 bucket or Azure Blob Storage or as files on disk or really any URI supported resource. All right, a few use cases for Synapse. You can, of course, take Synapse and build a REST API from the ground up. A few other useful things: you can take existing scripts and utilities that you have lying around in the environment and expose those behind the REST API. You could write a data API with Synapse by using the data handlers for direct DDL and DML support. You could expose vendor tools with a custom REST API. So this is useful if you have tools in your environment to administer, say, backend resources, and you want to expose those to customers for self-service, but you don't necessarily want to delegate the tool itself. So take the vendor tool, expose the REST API in for it, delegate it to customers. Lots of useful things there. Or you could take an existing non-REST enabled application and you could expose a REST API for it altogether. Again, this is kind of useful in self-service paradigms, or if you want your applications to be able to participate in an SOA environment and you don't otherwise have a way to do it, Synapse is a fast way to take that and slap a REST API in front of it. Shown here in the green box is the default execution interface for Synapse, but as I mentioned before, you could always put a custom URI in front of that. All right, well, that's it. So here's a few links about Synapse. You can visit these if you want to know more, or you can watch more videos. Thanks for listening.